SID 1802558. This is the penetration test of Dead Duck Publishing Limited. For the purpose of this pen test, we will be attempting to gain root access and discover information about two given servers. The MAC addresses of these servers have been provided to us in the interest of limiting the scope. The MAC addresses provided to us for this pen test end in 0C, 03 and 231B. In the interest of time, I have pre-prepared any long scans that will hinder progress. To start this pen test, I'll perform a network scan on the subnet of this Kali instance. To find this out, we will do ifconfig and look at the IP address assigned to it. From here, we can do nmap-sn on the 192.168.9.0/24 subnet to acquire all the MAC addresses of the data center. Scanning through, looking for our given MAC addresses, we find 0C03 with a 129 address and 231B on the 135 address. From here, I decided to do NMAP scans on both of these. For this particular scan, I did /SS-SU-SV-SC-OA on the 129 address. From here, we can discover there is a Debian instance. We can clarify that further by seeing that is a Linux kernel. We are also looking for any notable open ports. For example, port 9090 with an FTP process running on it with ProFTPD as the application, or NTP, for example. As far as low-hanging fruit, so to speak, there is no web server open on this address. Looking further into .135 with the exact same scan, we see that there is a web server on this one, and we will immediately look into this. There is also DHCPC, RPC bind, and NTP open notably. We will start by looking at the OpenVAS scan. If we look directly at the high vulnerabilities that it has found, it has only found generic vulnerabilities that are just simple update and it will be fixed. As far as mediums, same again, and lows, same again. From this, we'll have to do a Nikto scan. The Nikto scan I prepared earlier has been captured as a screenshot due to it being in a separate instance. The reason for this is if we look at the web server itself, we find that it is a MoinMoin instance, and this particular MoinMoin instance has a rate limiter on it which will throttle you and stop you from using the web page if it receives too many requests. Nikto, unfortunately, does trigger this. As such, I have it here. Within this, I can find that it is MoinMoin version 1.7.1. When we look specifically for exploits on 1.7.1, we find a path traversal and a cross-site scripting. We'll start with the path traversal. Seeing it mention a specific Python file and specifically 1.7.1 as a version it works on, we can look further and find that it is within the Metasploit framework, which is built into Kali. If we run MSF console to load up Metasploit, we can search for the exploit within the Metasploit database. See it there, so use 0, we want to show options. We see we can provide a password, a username, the host IP, and a writable page. For the purposes of this as well, I have already created Wiki Sandbox as a writable page. And we can immediately set our host as 192.168.9.135, as that is the web server address. We will then navigate to the login option with the intention of using SQL injection to retrieve a name and a password from the database. However, it appears we can just create an account very simply. For the purposes of this, we will name it Metasploit with a password of deadduck123 with an exclamation mark at the front. With an email of Metasploit. Let's save that account, click the message. If we run back here, we will set username as Metasploit and set password as deadduck123. From here, we should be able to just exploit, and this drops us into a reverse shell. By using the whoami command, we find that we are the user www.data. This unfortunately is not root, however we can use privilege escalation exploits such as DirtyCOW. If we look within Kali using the search exploit command for dirty, we see there are multiple instances of the DirtyCOW exploit. The one I've chosen to use is 40839, which is one of the scripts built in within Kali. I have already moved this to the root directory here. As such, we can navigate to the attachment section. We can upload said file, and we'll name it dirty.c. As you can see, I tried to overwrite the file as I have already uploaded it. However, for the purposes of this, I will just prove that I can do it. Upload, and we can see it's been uploaded as metasploit.c. By moving back over to Metasploit, we will need to navigate to the folder where the attachment has been saved. Before we do this, however, I would like to spawn a terminal, as it will make navigating easier and will be required later for the exploit. From here, we will go to the user folder. From there, we can go to local, jet, and then we find there is a MOIN instance. From there, we're looking to navigate to the attachment section. Because it is a wiki, we are looking for a pages section, potentially under the data section. And then within this, there should be a pages directory. From there, we can go back here and see we are on default page test. So if we cd default and then we tab, although it hasn't automatically completed, it should have completed from the reverse shell's perspective. Correct. And if we look, we are looking for the attachment section. Within this, we see Metasploit, or Metasploit in this case, .c. As mentioned earlier, I have uploaded dirty.c as well. For the purposes of this exploit, we will be copying Metasploit.c to /temp. I will also be renaming it to dirty.c, as that is the name of the exploit. Now if we cd /temp, we can see dirty.c has been created. As this is a C file, we need to compile it. So it will be gcc pthread dirty.c -o 30 -l crypt. Then we do ls again. We see we have a compiled one. And as such, we should be able to just run dirty. It is now asking me for a new password. I'll simply press return and it should create a blank password. This exploit will take a little while to run, so while this is running, I'm going to go look into a OpenVAS scan for the .129 address. So if we go back here, tasks, we see the full scan created earlier. This was the deepest scan available on OpenVAS. We jump immediately to the high risk section and we see the ProFTPD instance running on port 9090. It has a backdoor vulnerability. Looking more into it, it is version 1.3.3c, and when we look more into that, we find again it is in Metasploit. As we have a instance of Metasploit running already, we will open up another. And we will search for ProFTPD. As we can see here, exploit number 4 is the backdoor. So we use 4, show options, and we see all we need to set is our hosts and our port. The R host in this case is 192.168.9.129, and we remember from our earlier NMAP scan that it is on port 9090. From here, we can just run the exploit. And if it has now created a reverse shell for us, we can simply check, who am I? And we can see we are root. As such, server 129 has been successfully exploited. If we check back in with the previous exploit, we see done. A new user has been created, so we just return to get back to our terminal. We should now be able to su as firefart. Password, we left it blank. We'll do who am I? We see we are firefart. If we do ID, we see we are ID 0 root. This exploit has successfully overwritten the root user account with a user named firefart with a blank password. This means that server .135 has been successfully exploited. This completes the pen test for DirtyCOW Publishing. For further information and more security-based problems, please see the attached report. All information gathered in the report was gathered as a root user from the vulnerabilities that have just been exploited.